Hello, hello, hello. Welcome to AppNexus and Engineering at Scale, where we keep on the proud tradition of giving engineers free beer and free food. It's a very important tradition to keep up. It's, I believe it's fuel. It's called fuel to some folks. So this is our bi-weekly talk where we just have interesting folks from the tech community give speeches. Next 2 weeks, Theo Schlossnagel from Omni.TI and Search Conference is speaking. I don't know what the topic is yet, but it's going to be pretty cool because he does really amazing things. We're also going to launch this series in Portland in June 5th, which is really awesome. So Jessica Edwards over there has been hard at work at this. So I'm sure all of you guys are going to jump on a plane and fly to Portland for this. But just so you know, June 5th in Portland, first one ever. So that's kind of the stuff I have to, say at the beginning. But today we have a special guest with us, Daniel Doubrovkine, who's going to be talking about building and scaling a test-driven culture. Now, for those of you who know me here, you're probably wondering why I'm here. I'm the one talking about test-driven cultures. I think my boss is trying to be ironic. But no, this is a really awesome topic. And Daniel, AKA DB, is pretty much a tech manager, an entrepreneur, and a cheerleader of open source projects. I like to think of him just as a cheerleader. He also has had a music career of one day in Moscow, which he told me about. You should ask him about this sometimes because it's a pretty cool story. But no, really, it's a pretty great story. So he is a co-maintainer of Java Native Access and Ruby Grape, which are pretty popular open source projects. He also built the first shared source framework at Microsoft called CoreXT, which they're still using today after 10 plus years, which is also pretty awesome. And I think the most awesome part, this is a man truly after my own heart. He has a deep passion for technology and art, and he's now the head of engineering at Art.sy. So without much ado, further ado, DB.
Can you hear me? The mic is working, right? Let's give another round of applause for an awesome band called Magnetic North. This is my payback for my non-existent music career. Thanks for having me. Thanks to AppNexus for having me here. I'm going to talk about building and scaling a test-driven culture. So a little bit of who I am. I work for a small New York startup called Art.sy. It's artsy.net. I encourage you to go visit, join, and so on and so forth. And so this talk is going to be two parts. I'm going to talk about some tools and technology we use for testing and our approach to testing and what we have built in both from the tech perspective and from the people perspective and how we see testing in general. And then I'll talk about the culture of testing and what I think a working culture of testing is. And I've looked at many projects over the course of the last 10 years, some successful, some unsuccessful. And in many ways, what I think we have built is not necessarily on any of the extremes of that. The first thing I want to say is that everything I learned about testing and test-driven development, I learned it from open source. If I look at the history of the things I worked on, and I really divide successful, from the technology point of view, products, components, systems, and unsuccessful ones, and the business is a whole other question and problem, then I find that a lot of the successful open source projects have a very strong testing foundation. And what do I mean by very strong? I want to give the first example of SQLite. How many of you have heard or used SQLite? Hundreds of hands in the audience. Awesome. So the SQLite team has a 1-to-0 dev test ratio. It's not a number. Basically, there are no testers. And this team managed to produce 1124-to-1 ratio of test to code. So there are 1,000 times more test code than actual SQLite code. Actually, SQLite itself is pretty small. It's incredibly reliable. It's very cross-platform. It has one of the most difficult environments in which it works. It is tested and in which it runs. It runs on your phones. It runs on PCs. It runs on every operating system you can imagine. It runs on boats, on airplanes. You've seen it everywhere. You use a ton of software that uses SQLite, and you might not even know it. So how do they do it? They rely on automation fully, and they will never accept a piece of code without extensive testing. And the result is a rock-solid product. So I think it's pretty amazing. This is a project with relatively little governance. There is little management saying what to do and how to do things. And yet there is this huge amount of test code. So I think that's really, really good. Now, a typical project in the corporate world that I have seen and I have worked with, and this ranges from companies like Microsoft, the best of the best technology companies elsewhere, small startups, and so on and so forth. They usually have about a 2-to-1 dev to test ratio. So you'll find that developers outnumber the number of individuals that are dedicated to test. And you'll find that there is a very questionable inverse ratio of test to code. It's often unclear. There is some automation in testing, so some components will be automatically tested quite well, and then others will not be tested at all. And then some people will really be driven by testing, and they will want to test what they make themselves. Others will want to rely on QA people. Another group will be saying that it's all broken, and so it doesn't matter at all. We can just do whatever. So it's really an animal with different colored stripes, and that's a more common environment that I've seen in larger corporations, especially. Different groups just do different things. Now you should notice that different groups they can tend to merge and get reorged. So despite the fact that maybe one group has some good culture of testing, as soon as they get merged with another, it all goes out of the window. So the result of that is that in the worst case scenario, some of their software doesn't even install. And we did a lot of component testing. We did a lot of this kind of testing, that kind of testing. And then when it reaches the customer, it doesn't work. I think not installing is like the ultimate irony in all the effort that an engineering team does. If you deliver shrink-wrap box software, it's a very specific thing. It's like we burn it on a CD. I'm from that time. Ship it on a floppy to someone, and then put it in the computer and run it, and then it just like nothing happens, or maybe there's an error, blue screen, or some kind of message says sorry, could not find files, dump, and that's it. You lost your customer right there, and that's actually pretty common in quite a bit of software. So I work for a startup. We have 12 engineers. We've grown from being 2 or 3 engineers to about 12 over the course of the last couple of years. And how do we compare? How do we fare with both of these very extreme sides of testing? So we have no testers. We have no QA team. So we have the SQLite ratio of developers to test. And we have about twice as much test code as production code. We rely on full automation and continuous everything. So we use Jenkins CI for continuous integration and all that good stuff. And we actually sleep quite well. And I think that's a good testament to how much we rely on testing, is that we feel like the systems that we have will run and will run fine without us actually pedaling on some kind of bicycle while, as the system came up and now everything is exploding, so we need to do things. We actually rely on tests. So that means that when we push something to production and tests have passed, we have high confidence that that will actually work. We almost never have to roll back things. So I feel like we are somewhere a little bit closer to the SQLite example, but we're still very far from their example. I can't say that everything we do is super rock solid. I can't say that we have achieved kind of the holy grail of automation. So I very much believe that we're in the middle between the kind of disorganized, messy, striped environment of my second example and the awesome, very reliable SQLite picture. So what's the size of the thing we're looking at? It's not very big, you might say, but it will give you some context when we talk about the culture of testing. So we started as a single Rails application, and we have started writing tests from day one. And that's something that in the Ruby world generally is the norm. Why it's the norm? Well, Ruby is a scripting language. If you don't write tests, you actually have no idea whether it's going to work. It's not like there's a compiler to catch. You actually have to exercise the functionality to see that it would even connect. So we have today 5,500 tests, automated tests for the website alone. It takes about an hour and a half to run. We split that across 6 machines. And we use Jenkins for that. So as far as the website goes, and I think that's one of the things that any developer at Art.sy will tell you, the thing that we have is actually pretty big for a typical website. It also is pretty cutting edge in terms of UX experiences. So we've dealt with some of the nasty problems around test automation there. So how do we do it? We are very much subscribing to the RSpec behavior-driven development philosophy. If you're not familiar, I recommend the book. It's called the RSpec book. It's very simple. It says that most tests fit the framework of when something and something else, that's what's supposed to happen. When we have a 2 and another 2, and we add them up, it should come up as 4. It's pretty straightforward. And you could apply that in a lot of examples. So we do that using for data models. So let's say we have an artwork and an artist, and we need to make sure that, for example, an artwork always has an artist, if that's something that we want to have in our model. Then we'll write an example like that, and we'll say, a new artwork has an artist. And that would be an example of something that is true. And so we write tests like that. For APIs, we make actual HTTP requests. And for integration, we use something called Capybara. I'll talk about those in detail. So here's an example of so our backend is MongoDB. And here's an example of a model test. We use actual databases as our test environment. We found in the past that when mocking the data and trying to test the model is actually not very useful. Imagine you have a unique key constraint inside the database, and you try to insert the record. Well, if you aren't actually exercising this kind of database level unique constraint, then you're not testing anything. Or you're not testing what it's actually going to be in production. We try to get as close as possible to production. And so this is a controversial example, but we use a real database to do our model level tests. And so here's an example of a test. This is an artificial one. Let's say we're dealing with splines that can be reticulated. And in the context of a spline, let the spline be an actual spline. So that fabricator is something that is going to create a record in the database. We use a library for that with maybe some fields on the spline that will actually write to the Mongo database right there when this code is hit. And then we expect that reticulate bang, which is something that why I love Ruby so much. You can be very explicit. If it's going to make changes, you put a bang in at the end of the function. It's just a function name. So you say reticulate the spline. And you expect that the reticulated spline will change the number of reticulated splines in your system by 1. And so that's a straightforward test. Reticulate the spline, expect that it will change the number of reticulated splines by 1. And we will tear down the entire database after each test. And we will restart with a clean database right for the next test. And we run thousands of those. And it's actually pretty fast. Mongo is in a memory database, with all the good stuff that comes from there. So we test models and the methods that are on the models, the kind of the functionality on the models, doing just that. We have thousands of those. We actually have 2,156 model tests. Now the API is kind of the next level. Now an API for many will be kind of a CRUD API. We do have a lot of CRUD happening in our API where you create a spline, get a spline, reticulate a spline, that kind of thing, delete a spline. But most of our APIs actually do more than that. So this example might be a little light. But what we want, an API is a great place to insert a layer that is testable. Because it's already an interface. And as we all know, testing on interfaces is awesome because you're testing the boundary. So an API is a perfect place to insert a test. So how do you test an API? You make the API calls. If you're tearing down the data every time between every test, or you can always set yourself up, and you can always run something and see that it actually worked. And API tests are some of my favorites. So here's a simple test where we're going to post API spline with the name test, and we expect that the response is a 201. That means that we have created a spline. That's very HTTP. And we expect that the number of splines has changed by 1. So it's interesting because this tests 2 levels. This tests that the API responded in the correct way. This also tests that there is a side effect, that a spline has been created in the database. Something that in the production code you can't really do. You can't really reach deep inside and see, oh, now you've created an extra thing by using your hands, kind of go in the back end and seeing it. So another way you could test this is afterwards by getting all the splines and making sure there is one. So that's kind of something you can do if you don't want to really go and directly count the number of items in the database. So we use Grape for which I'm the maintainer of. It's an awesome Ruby DSL for APIs. And these tests match really one-to-one the layout of the API. So it's easy to know where the tests live. Just like the model tests correspond very much one-to-one to the layout of the model. So if I have artwork RB, I also have artwork specs RB in the models folder. Same thing for the API. I'll have a layout of the folder structure that will match very much the API. So it's a reflex for developers to create tests at the same time as they create models or as they create APIs. The hardest part to test is integration. If you've seen the website, there's all kinds of things going on. And it's pretty rich. You can go to the homepage and we load the feed of stuff. We have all kinds of things happening on the page. You can navigate forward, backwards. We keep history. We have events firing in thousands left and right. It gets pretty messy. So what do? Well, we roll up our sleeves and we use something called Capybara. It's a Selenium-based, just a small wrapper on top of Selenium. What it does, it makes Selenium usable by humans. So you don't need to wait. You don't need to explicitly wait on events. You can say, click a button, and Capybara will actually wait for something to happen. Will wait for maybe Ajax calls to finish, whatever else needs to happen on the page. So it makes the test code actually much, much smaller. So here's an example. We're going to fabricate a spline, and then we're going to visit a page that displays a spline. And in a RESTful way, the URL of that is probably spline with a spline ID. So visit the page and expect to have somewhere in the DOM of the page a spline with a record with an ID of the spline that we have created. Very straightforward. And notice that unlike any equivalent Selenium Java code, I don't have to do any kind of waiting. It's really exactly the minimum test code that you would write for something like this. Visit a page, expect a result. Pretty straightforward. So we have 1,400 tests like that. Now, something happened quickly. So we went tagged along, and everything worked fine, and we had a reliable site. Then we launched publicly via the New York Times, and this is what it did to our traffic. It ballooned very quickly. And now everything became much more complicated. The things that became much more complicated started with the fact that we doubled the size of the engineering team. And the technology for some of the parts that we're building became clearly inadequate. So for example, we used to have an admin and a CMS interface that was bolted on top of our application. It was kind of like a quick and dirty thing that we threw together so we could manage our inventory and not spend too much time building it. And now we are looking at having hundreds of partners that need to manage their own inventory. So we already built a good permissioning system in our API, but we haven't built a UI that uses that. So we needed to build a new application that would talk to our API and deal with the whole management of our inventory. So we chose different technology to do that. We started writing a lot more JavaScript and built node-based applications, very front-end focused and very much detached from their backend. So now those are going to be talking to the API, but now they need to abstract the API. We actually can't be launching a server every time we need to do a test, clearing a database in the backend or anything like that. That's just a huge integration problem. So we needed to create all these different applications. We built a live real-time event system. So we have a model where you can follow people. And as you follow them, you're subscribing effectively to notifications from them. So when they post something, we need to deliver that post to everybody who follows them. So it's kind of like the Twitter model. And we need to do that real time because one of the scenarios was we let you follow people during sign up, and then you flip to the homepage and you see the data from all those people that you've just followed. And it all seems seamless and transparent. So we need to turn around that data really fast. So we built a completely new system called Flux. It's actually open source based on Redis to be able to do the kind of aggregation and math on top of this data. And with all these tools came a lot of new complexities. Now we have 10 times the number of services that we had before. We're no longer a single nice Ruby shop where we have a small Rails application and everything is peachy because I can test everything end to end. So that came with a ton of challenges. So one of the wins for us in terms of technology was to start doing JavaScript testing. We started with Jasmine, and this was a year and a half ago. So the variety of this stuff is already obsolete, and I'll do a quick list of what's not obsolete today. So a typical Jasmine test, we'd use CoffeeScript to write our views in these applications, and it's a Backbone JS application. So you can create a view, you can assign a model to that view, and this is a Backbone model, and then you can do something like change a value and expect it to fire an AJAX request to update, right? So that's a good test of this Backbone view. Update some data, make sure it's been sent to the server. We don't expect, our API is tested, so we don't need to know whether that actually has been written successfully, but we just care that it has been sent. So we'll examine the AJAX request for the data being sent. This is a real test from the code. So today, in more recent projects, we use Node for headless unit testing, Mocha that gives you the RSpec-like testing behavior, so you can write the whole BDD-style tests. I love Sinon. I don't know if it's pronounced right. Sinon lets you stub everything you want. So one of the things you can stub is AJAX requests. You can stub things like API calls, single API calls, all of them, and so on and so forth. So you can trap everything that's happening in your in communication with outside services, and our own services are just outside services for these apps. JSDOM lets you simulate DOM API, so you can create something on, let's say, you give some HTML, and then you can go and manipulate that without actually having a browser. So you can do this headless browse, and Zombie is another way of doing that. So just some ideas of how we do testing today on those. So this is a good primer on kind of the scope and the technologies that are involved. But these are very important for engineers to understand, because after all, one very essential part of having any test-driven culture is doing the actual testing. So it doesn't happen without those tools. If you don't know how you test your software, if you don't know what it actually takes to write a test, then you will never achieve a solid test-driven culture. So what is test-driven culture? So test-driven culture for me, first of all, is that tests is just second nature. When I start working on a feature, a change in the model, an API implementation, anything, testing is not something I do afterwards. It's not something I do necessarily up front, as TDD will tell me. It's just something I do at the same time. I don't deliver any code that does not have more tests than the code with it. And really, it just becomes part of my life. And that applies to every single developer. We have developers who will send excuses saying, like, I feel like this is poorly tested with a bunch of pending tests because they're not sure. They didn't have the time or didn't want to spend the time to write them all. But they're saying, the reason I'm not doing this is because I don't think this feature will survive more than 3 days. We're just experimenting. But they took the time to at least spec out the behavior of those tests. So in Ruby, you can write pending, blah, and that becomes a pending test that doesn't actually run. It will say, I have this many pending tests. But we know that those are there and they need to be filled out. One very easy way to start testing and kind of create a test-driven culture is to take bugs that appear in a production system and make them into a test. And notice that sometimes these bugs are really trivial. Sometimes you know exactly what the problem is, but if you haven't written a test for it, then you haven't learned anything. You just fixed the bug. So I would take any bug, any given day in our production environment or any other environment, if somebody found an issue in our staging environment or something like that, I'll turn it into a test. And once I have that test, I'll make the fix. And it's kind of nice. You had a failing test. You fix the bug in a trivial way, and then it passes. And that's a beautiful iteration. Now you can submit a pull request, and you're done. For features, I usually start with building infrastructure for tests. So if I'm building some new UI, I'll write some tests, visit a page, expect to see something, and kind of roll this into a normal behavior. So a feature often starts as a test and becomes a feature slowly as it grows. And it's all about how you feel as a developer. So if you feel the stress about does it work after you've written this huge, gigantic feature, the tests are there to absorb it. If you have 100 tests for half that many lines of code that you've written, and they're all passing, that just becomes mechanical, and it's 4 o'clock in the morning, you still decided it's a good idea to be writing that code, then having tests is kind of nice to catch all the other mistakes you're making, because it's crazy late and you shouldn't be doing this at all. So as a team, especially when you have other people that decide to work those late nights, which I don't recommend to anybody, it's nice to know that there is good test coverage, because even if I don't understand how something works, I at least see these examples of what it's supposed to do. And sometimes we have some pretty mean math going on, and there's some obscure logic. And I will read the comments in the pull requests with the peer code reviews. And I'm reading it, and I'm like, OK, I think I understand the math, but I really don't. And then I'll look at the code, and I think I understand the code, but I really don't. And then I'll read the tests, and now at least there's titles on those tests and explain all the individual cases. And learning by example is awesome. It's more awesome than getting a long explanation of the formulas that are being used. And so tests are a good place to do that. And finally, it's whether you can have an awesome test-driven culture, but ultimately the measure of success that the software works. It's useless to have a great process around testing. It's useless to write all these tests if the software doesn't work. And so you have to find a good balance there and to make sure that what you're delivering is actually running at the end. And so that's a good measure at the end. So how do I know when I see a project that has a good test-driven culture? It's an everyday little thing. So here's an example from a GitHub repo of an open source project. And that's actually one of the things when I start contributing to an open source project, I look for this kind of stuff just to see how the workflow of things happen. So I don't know if you can read this, but this is somebody opening a feature request. So it was opened as a bug. And it says, I am trying to put or post a JSON array to this API, and I'm getting an error back. And the description is I cannot do blah. And reading the description of that, which is not on the screen, I see, this person has a point. We actually don't support that, so it's actually a feature request. But nevertheless, they think it's a bug because arrays are just normal style JSON data. There's nothing special about arrays. It's unusual in the scenario that was described, but it's nothing special. So my reply was, yeah, I think you're right. This is something that is not handled, and I'm not sure. I think the problem is in rack, which is some middleware on top of which this library sits. But why don't you start writing a test for it? And the response to this is, sure, I'll do it. And the next day, there's a pull request with specs for number 347, which is an issue. And it's actually a repro of exactly what the person is doing in the framework of the library. And it has, it's a 100% repro of the problem. And I look at that, and I say, now I can go and actually fix the issue. And if it passes that test and passes all the existing tests, we're done. Basically, that's a clean way of doing it. So I've just made a contributor to the open source project by asking him to write the test first. I've practiced BDD, which is what lots of people are saying I should be doing. And then I implemented an issue. I focused on the thing that I really like to do, which is add features and do the cool engineering stuff. Tests are not as fun, maybe too boring, but I just had somebody else to do it. And you know what? If I didn't have time to do this fix, it's very likely that somebody else, including the person that opened that issue, might have picked it up. Now that they have a test, it's quite likely they would have fixed it as well by themselves. Because once you have a test, and you know that there is a ton of tests in the system already, you will actually try to make a fix. And you're not as scared of making a fix. So the other aspect of test-driven culture that I want to highlight is that there's a cost to general software failures. And this will be a little parenthesis. So when Art.sy started, I used to have the CEO, and we're like 5 people. I used to have the CEO run to me and said, don't touch anything. If the site goes on fire, I'm doing a super important demo to an investor. This is like life and death. Tomorrow, it's at like 9 a.m., I'm doing this demo. It's like whether we'll get money or we won't get money, we'll go out of business tomorrow. Don't touch anything. Like, no stress, right? All my continuous deployment, all that stuff, forget it. Turn everything off. Everybody hands off the keyboard. We're not doing it. And then like demos 3 times a day. Then once we were live, he would come back and say, we have some users, a few thousand, and it's good. And it says, very important person is going to use the site tomorrow. And don't touch anything. It's going to break because it's such an important person. They have such a huge aura. And I'm not kidding. These are people who are like, Tim Cook, Apple CEO. Like, he's going to be using the site tomorrow at 9 a.m. because a friend of a friend is going to be showing him the site. Don't do anything. Like, no stress, hands off the keyboard, stop developing everything. And then we have hundreds of thousands of users. And somebody comes back and says, there's an article in the press tomorrow. Don't touch anything. If we tank on that, we'll have no future. So it gets even worse when you're selling stuff, because now we have an important sale. And if that sale doesn't work, then we're betting like our reputation on this. So you can see how the cost of failures exponentially grows. But the truth is that the stress level of the team is exactly the same, just that the cost is shifting. It probably costs a lot more money to the company at the very end of this spectrum, as you're making millions every day. But the importance at the life of the company is exactly the same. In the very beginning, you'll go out of business if you fail. And you'll go out of business at the end if you fail, the same way, at any given time, at any given moment. So you have to build something that's sustainable. You can't be always borrowing. You can't be living on borrowed time. So you need to create a test culture where if your tests are reliable, you'll be building on top of something. So as the scale grows, you can also have, react the same way. I react about the same way now when we're selling things on the website, as opposed to having an important investor that was on day one of the project. In some ways, I think it is harder at large scale, but in some ways I think it's easier. It's always a matter of life or death. It's always for the management, for people who are consumers of your technology. It's always like to be or not to be, the big philosophical question that transforms into an exploding nightmare when things don't work. When things work, that's kind of expected. You've done your job. Good stuff. So in order to grow with the scale of the systems, you have to really focus on testability of individual components. So we had this big Rails website, and it looked like the giant bunny. That's an awesome artwork, by the way, of a Chinese artist. I recommend you buy it. And it became pretty big to handle, so we had to break things apart. And we had to start testing individual components. So testing individual components means that you can test those parts, but you also need to be able to do the integration testing of that. So engineering for testability is really an unsolved problem. I don't have anything too wise to say about that. So I'll just leave it at that. A lot of people say, what about UI? Well, UI seems like a hard problem, so I'll just say, deal with it. UI is no different testing from anything else. It's slightly harder because maybe you're using a browser, maybe you need to pop it up, and maybe you need to click on something. Well, we've been clicking on browsers for generations now. I've used Netscape 4. And we had no dev tools when you wanted to know what was going on in those things. Handwritten HTML or used front page sometimes. But today, we have pretty good tools, and there's no excuse to not test UI. And my JavaScript example is really a good list of the tools that can really meaningfully impact how comfortable you feel with testing UI. It's a little hard to start. There's some ramp up to do, but you'll thank the people who have worked on the getting started, because then you can knock out these tests one after another, and you can really make your development super fast in these headless environments where tests take like 3-5 seconds to run. We have some projects that have 5,000 tests, take 5 seconds to run. How awesome is that? I can tell you the Ruby project is not one of them. So deal with the UI. It's not that difficult. On the question of ownership, when you architect for testability, you still have these integration points. So this is an example of a bug reported on the Grape forum. Again, I'm picking examples from open source. You can look at them later. And so somebody says, Grape doesn't work with JSON-P. I'm sure you're familiar with JSON-P. It's, you tag some parameter to the URL, and then you get these wrapped JavaScript responses, so you can kind of do cross-domain data retrieval. And I believe it works because I've made it work, and then somebody else says it doesn't work, and they say it's Grape's fault. Well, what's the right thing to do? It would be nice to ask them for a test for repro, and we certainly do that. But at the same time, sometimes it means that me as a contributor to this one small component, I need to roll up my sleeves and go through these projects and get it set up as a whole thing. And I need to see it not work. And then I might need to dig it up. And very often, I will find that something else is the actual problem. And that's OK. And I own a component, but it doesn't mean that I live in my walled garden of my little world, of my little thing, or big thing, depending how complicated or not complicated it is. It is a culture of collaboration. And oftentimes, these issues, they'll ping pong between projects. They'll get moved around. People will say, we've been digging this thing, and it ended up being a bug in the Ruby interpreter. Or we've been digging it, and it's a bug in RAG JSON-P or something else. So it's hard. It's not meant to be easy. There's a lot of moving parts. I know at AppNexus there is a pretty large platform with lots of moving parts. And when something doesn't work end to end, you actually need to be able to roll up your sleeves and go and look at all these other parts. And that also means that each one of these other components needs to be engineered for testability of themselves alone and with other pieces in mind. What happens when I do all this investigation work and I suspect that the problem is in RAG.jsonp, a component I don't own? I check out the source. I try to write a test only in that component. And if I have repro'd the problem, I'll quickly look, can I fix it? If I cannot fix it, I'll open a bug that will have a spec and a repro of the problem. What's going to happen next? If you open a bug with a repro, it usually takes 24 hours for one of the project maintainers to fix it. Why? Because it's easy. They know the code throughout. They know the best way to fix it. And they know, they feel like you've helped them. And they'll return the favor. Next time somebody says, RAG.jsonp doesn't work, and they'll give an example, well, great, but actually go dig it up, and they will file a bug, the same things in my project. That actually works really well. So in testing, there is a lot of people you cannot count on. You can only count on yourself. You can't count on management. Testing is not a management problem where somebody, by magically moving people around or by telling them what to do, will create a culture of testing. This is very much a grassroots effort from the bottom up. You have to do it yourself. You have to start with small things. Start with, my favorite is to start with bugs that become tests, that become fixes, and slowly ramp it up through the entire organization. You can count on money. You can throw a ton of money at the problem, but it's not going to write tests. And if you throw money at consultants who write tests, then in the end of the day, they will basically write a bunch of tests, and they'll leave, and you'll be left with a bunch of code you don't understand. And you've made no strides in engineering for testability, and you will have not taught any of the developers on the projects themselves how to write code or how to write tests, which they should be doing as they write the new features. So when you have some traction going on around test-driven culture, when you feel like you're making progress in tests, and it's never going to be the end of it. It's always going to be kind of an incremental, slow way till you get to that awesome holy grail of some SQLite-like project, which really works. There's some struggles you're going to have to go through. One of the things that I like to do is to try and remove people who just talk about testing. Those who walk around and say, we should be doing testing, we should be doing testing, we should be doing testing. Do some testing. Try to separate those that talk about it and actually do something about it, and then promote the ones who are actually doing it. And give them more tools, more hands to do more of the same. When something works, just repeat that. Open source projects don't have QA teams, so it's very natural for them to be test-driven, because otherwise, you're not going to get many contributions. Some of the best open source projects are thoroughly tested, and that's because the people who write them have learned the hard way that that's the only way. So hire those people from open source projects. Go after the ones that are building the open source projects that you are using today, and hire those. And they will bring the test-driven culture into your organization. There is a big conversation around whether, A, you should have a QA team, and whether you should have an ops team to which you can kind of throw code and expect them to run it. Kind of like, worked on my machine, now it's an ops problem. Remember that meme? It's like a girl standing in front of a house on fire. And she says, worked on my machine, now an ops problem. So there's these debates. What happens when that one is responsible for putting the code in production? If you can carry the code from your particular desk to production all the way, you'll actually be much more motivated to test it and to make sure that there is enough automation and enough infrastructure to make sure that this thing works. So I'm a big supporter of not having a dedicated QA team. I'm a big supporter of not having a dedicated ops team. It is often very difficult, and I think that in some larger scale enterprises, it's much, much harder not to have people dedicated to, say, ops. Because there's a ton of infrastructure to build. There's a ton of things that you want people really specialized in, running databases and things like that. So if anything, they need to be much more integrated with the development teams. And that's a whole other topic of conversation. Same things for QA. I encourage QA people who have the job of testers to go into to be merged into the development teams and become developers and become engineers and test. I have a good friend, for example, who works for Microsoft Security Research. He's now a security researcher, but he is actually a tester. And what he does is play with the new APIs that the Kerberos team comes up with and tries to do performance testing, large-scale analysis, security analysis. He is the one who takes the bugs that you report to via security channels to Microsoft and will try to repro them. And this is an awesome job, but it's a kind of test engineer job. It's not clicking the button that is automatable. Everything that's automatable should be removed. So I think that the QA function has evolved. It has evolved to something very, very different than somebody that just ensures that this particular version of this particular software in this particular very canned environment works. I think the time when we have people who just do just repeat the same mechanical operations is over. So for QA engineers, you have to go closer to the developers and do more of the developer work. And for developers, you need to do more of the QA work. And eventually, there's a good middle there. So some of the other elements of removing the safety net is use a crappier language. I love Ruby. It's very beautiful, but it has its own disadvantages. It's slower, and it has other problems. But it's a non-compiling language, so here's a simple way I remove the safety net from under me. If I type out the code and hit reload on a page and it works, it's great, but I probably broke 10 other things. So without tests, most of the time my site just does not work. And so using interpreted language is actually a wonderful way to write more tests. Another way is to do DevOps, which is find ways to let engineers push code to production. In a small team like mine, which is 12 engineers, this is all we do. And when it's pretty powerful when you have a new engineer that comes and in the first day he made a small change to the site, and then he hit that deploy to production button, and nothing exploded. And do I trust him? Maybe not yet. But do I trust the tests? Certainly yes. And if the tests were all green, then I'm perfectly happy that he does it. And I'm like, you know what? Just go for it. And I do have a backup plan in case something does explode. But generally it doesn't. And that's because we've invested in doing the kind of testing that we do. So that's all I have for you. I'll answer any questions. Thank you. There's some links on the slide.
So I'm curious, you talked about you've got like a really big test suite, and you're testing, for like sort of every piece of functionality or expectation, you have a test, and also you want to be able to look at the tests and understand them so you know what's going on and what the expectations are. You talked a little bit about how you guys manage that sort of pull between complexity and testing lots of stuff, and do you have like best practices for putting these tests together in a maintainable way? Is that part of what RSpec helps you with? I'm on a team here that uses PHP unit. We're PHP based on this team, so I think it's a different thing than RSpec, it sounds like, but I don't know how that contributes to that.
Yeah, so I think that I tend to think about tests as positive examples most of the time, and not try to make long, complicated integration tests that demand many, many steps, which would match the site, right? And you'd think that if the site is so complicated and there are so many moving parts that I want to really test them all together. But I found that before we can do that, we need to test a lot of small things. And that through small things, we cover about 85% of the cases. And then we might adventure ourselves into kind of the more complicated click-through scenarios. So we try to decomplexify our tests as opposed to ramp up the breadth and the depth of those tests. We use also very little for knowing what we cover. Generally, we try to think of them as features. So when a feature is user, we have favorites. You can add things to favorites, you can remove things from favorites, you can do all kinds of things to your favorites. So we'll group tests in features, and when a particular area is not working as what we expect, we'll go and spend some more time on writing tests there as we fix the bugs that arise. Does that answer the question?
Yeah.
Hi, OK. So an hour and 20 minutes for a test run is far from the worst I've ever seen, but it's clearly not a test run that you want to do on every check-in either. And I guess you're saying that you don't mock database layer. Do you have a sense to what degree that contributes to the length of a test run, and whether running tests with mocked databases would get that down to a time frame that you could get closer to an every check-in type run versus a once a day?
Yeah. So you're right. 1 hour, 22 minutes on 6 parallel machines is a pretty bad run time. Although, to be true, we run that continuously, which means that in a day we'll have 10, maybe long developer days, let's say 5 successful runs of the test suite. So this gives us 5 points which we can deploy to production, because we effectively use that signal to say this is good to go. At this check-in, the thing can ship. And we have many more check-ins than actual tests, and developers run their own at the same time. And we use one of the Jenkins plugins to spawn EC2 instances to parallelize those tests, so each developer can do that. And I run my builds often, and I don't need actually a build every 5 minutes, although I'd like to. So I don't think it's that bad. Now, I do think at the same time it's pretty bad, because it would be amazing if I could run that in 5 minutes. And that's really a technology problem. And I wish more of our stuff has been built in this JavaScript, Jasmine, mock type, especially for the UI, because most of the time we spend in browser testing, by far. Removing the database with Mongo makes almost no impact, because 1, Ruby is pretty slow, and 2, it's an in-memory database, and you're not making any round trips. You're doing this on the local server. So I did some experimentation a while ago on what we're talking about, and this was like 10% of the time for just removing the database. But compare it to what it means to mock your data. I would have to fabricate some kind of mock model for every single thing, which means that either I'm creating these records and stubbing them. I have to stub all the fines. If I need to write that code for every test and explicitly mock things beyond just fabricate blah, then my code will become much larger. That takes a lot more time to write than to run. So database, not so much an issue. I can see how it's an issue with some other databases where the boot up time is pretty big. The browser testing is the biggest culprit in this whole thing. I think that if I were to redo everything again, I would continue doing real data with Mongo. I would continue doing API-level testing with HTTP requests with RSpec, and just as we do today. And I would completely move the UI out of this picture and do exclusively Jasmine or whatever more modern frameworks exist. And I'll probably have a component that's the API alone, all by itself, which turns around. If I parallelize it will be like a 5-minute run, right, at the most. That would be great.
Hi, great presentation, by the way. You've mentioned that you're using Selenium for integration testing, and also Zombie. In which case do you use which product?
So we don't use Selenium directly. We use Capybara, which lives on top of Selenium. We use Capybara for all for projects that are based on Rails environments. So things that started as Rails projects and that have UI that comes with them. All of our UI is written with Backbone, CoffeeScript, and all that good stuff. But when it's built on top of Rails, usually we'd use Capybara to click through things. And it's mostly an artifact of history. Everywhere else, we use node-based technology. And that's where all the other JavaScript test frameworks come in. So everything that we write today, modern, new projects, are always doing headless browser testing on top of things that you've described.
Right. So one of the things that seems to be common, especially for organizations that are trying to get into a test culture and especially trying to retrofit an existing code base, is what to test or going overboard with tests and not really having a sense of what value they're adding. So, for you guys, it seems like you're very feature related with your tests, but, do you have a sense using, I don't know, code coverage or something, like how much of your code is actually being tested and what value it's adding?
So it's a good question. As I said, it's important to know what value the tests are adding, and the other question was how much of the system we're actually testing. Now, we don't measure test coverage, which is I wouldn't say it's a philosophical debate. None of us really wanted to, so we didn't. It's not difficult, throw in the thing and you'll know what your test coverage is. I don't believe in kind of this is all the paths that your code can take testing. I'd say for sure we test 100% of features. We test 100% of APIs. We don't have any APIs that don't have a test, at least some test that comes with them. Same thing for a lot of the models. At least it's just because you can look at the list of models, the list of tests. So they usually map one-to-one, if not more. Now, what value that provides, that's a little bit more subjective. I think we look at how often we fail in production that could have been caught by a test. And the answer is very not often. It's very rare that we'll push. We haven't pushed anything catastrophic into production as far as I can remember. It's a tribute to how the system is architected, but it's also a tribute to tests. Because we have caught many, many times issues during testing. We had, it's pretty common for somebody to make a big refactor of, we have our inquiry process is changing right now. We have a completely different workflow around how you can make inquiries on works. We took the information about galleries public, so now it's all available on the site. It's happening live, sometime around now. So it's a huge refactor of the entire system. And it's like a 1,100 line, minus 1,100 lines, plus 700 lines code change. It's like 10% of the code base or something like that. So the developer who was working on it, his message is like, thank God for tests, because I found a ton of issues just by running that. And I looked at his history of builds that he's using our Jenkins for, and it's like fail, 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 fail. And you can see how the number of failing tests is going down. And eventually they all pass. And he's not deleting tests. He is fixing issues that he's introducing by changing that. So I just think without that, we can't pull off this kind of change. I'd be super scared about that kind of change. We have it's all over the place. There's every single thing that we thought about very, very thoroughly, art organizations, they're very particular about what you say about how it displays, what they want to see. We have these if cases left and right around what to show and what not to show. And so tests are the history of those discussions. And oftentimes you can go back to one of those examples and say, I'm changing this, and this is going to go away. What's the impact? You go to an art person, they'll tell you the impact is huge. You can't do that. So, and that's invaluable.
Just as a quick follow-up, you mentioned refactoring specifically. Have you run into cases where refactorings that you want to do require you to do almost more work in changing tests than the value that the refactoring would add?
So whether we've refactored anything that was actually more expensive to refactor in tests, yeah, I think that generally the hardest refactors where you take a component out, throw it away, and replace it with something very, very different that behaves in a completely different way. So it demands 50% of your time to rewrite the tests, and it's all over the place. So definitely, but I think it's worth it. I think if we look at time spent developing tests, it's huge. But I think if my choices are fail or write tests, I'll take write tests because I can do it calmly after I've slept well, and it's just like better than having a production site on fire or some angry customer telling me that he'll never work with me again.
On behalf of all the QA people, I want to just say that your point about QA working, being developers and the like is a brilliant point. I wanted to ask you about what you meant, if you wish to elaborate on removing the safety net about the developers and QA working side by side, because I find that, at least from QA tends to be the last line of defense before it goes to the client. At least that's the value, the added value that we're trying to bring to the company, where a lot of times our developers are just saying, they're not even looking at the code, they just put it together and, oh, let's QA fix it. And oftentimes we have to think like a project manager, like a developer, sometimes even like the client, to deliver and guarantee that the product is meeting the client's expectation. I wanted, if you could, elaborate on that point.
I think it's a very sensible topic because I think that removing the safety net is this one of the most unnatural things that we can do as humans. Let's just pretend for a second that there is no QA team and the developers are writing the code and giving it to the clients and it doesn't work, right? So on one hand, the business is failing, and that's maybe not acceptable, generally not acceptable. On the other hand, the reason why they right now give QA broken code is because they know you'll catch them, and they know that it will come back, and it will that there's somebody doing half of my work, which is testing it for me. So I actually I don't need to worry about it too much. There's always this other line of defense, and I think that's when you don't have that line of defense, then you have to do a better job. And I think part of what we don't like in other connections, we don't like when product management throws something over the wall and says like, build this. I don't care about your opinion. Just like build it. We don't like when developers throw this code over the wall to QA and say, hey, test this. Oh, it doesn't install. Why are you sending it to me? Customers don't like when they toss the product and it doesn't work, right? It's all the same problems. But when we work together in a different way, things get better. So removing the safety net means that we need to hold the engineering team, the developers, much more accountable. And sometimes it's done by not being there to protect them blindly. So I'm not sure what that means in a classical organization, but I do think that the first step is to converge development and QA into a single group. And when that happens, it's no longer I pass the code to you, because now you as a group are responsible for that delivery. It's no longer two managers who is responsible for the quality of the product, the QA manager or the development manager? If it's the QA manager, but he doesn't have the tools to develop better products. He just has the tools to send it back when it doesn't work. So I think like those teams should use one manager who's responsible for the overall delivery. And I don't think that this division of developer QA, that's very much a waterfall division of the process. I think that the developers should be doing testing. I think that the testers should be doing development. And after all, we'll all be. One of the greatest stories I have about incredible testers, I worked at Microsoft in a security-related group, and I had this. We're working on some nasty distributed crypto, and this guy was a test engineer. And he came to me and said, I don't feel right about the algorithms we're picking. I think there is a flaw. I'm going to demonstrate that it happens. I think it's a timing problem, and I just don't feel that it's possible. He nagged me for like 3 weeks about this. And I was like, you're joking. This is bulletproof. I have patents on this thing. And 3 weeks later, he built a repro, and he was right? I think this is the kind of job that anybody in test should be doing. Not like making sure that when I call encrypt, it returns a blob from that API. That's ridiculous. That's like, and every time I do a new release, we have to double check that that feature is still there. So I just think that they should merge. And when the team says we're going to build a certain feature, testing is not a line item that's somehow different from development. I think it should be just part of that. And it should be everybody's responsibility, shared equally. I tend to think about people as T-shaped people with broad interests and deep specialties. I see a development team with lots of T-shaped people. Broad interest, somebody is interested in development of the hardcore algorithms, somebody in user experience, somebody in testing, and somebody else maybe in managing this whole thing. And then everybody with their with those specialties accentuated, but everybody kind of looking all over the place and being able to do a lot of these things, maybe not necessarily all of them at once, but at least understanding and being able to articulate them and play anybody's role if they have to. Okay. Thank you. I want to remind you to pick up your garbage on the way out. And feel free to email me. If you have any questions, follow me on Twitter, email me. Go ahead, don't hesitate. Thank you.